Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in this video I'll be discussing with you all the problems that are based on feedback amplifier so that we can understand what kind of questions can be framed and how to tackle each type of problem. So let us see the first question. An amplifier with open loop gain AV, this is actually a misprinting, it is AV equal to 1000 plus minus 100 is available. It is necessary to have an amplifier whose voltage gain does not vary by more than 0.1%. We need to find the beta for the feedback network. So this variation is given in percentage, whereas originally it is given in absolute value. So if you find out percentage change in AV, it will be 100 over 1000 into 100, that is 10%. So it is saying that initially open loop gain has a variation of 10%, but we need to design a closed loop amplifier whose gain does not vary by more than 0.1%. So we want to reduce the variation in the gain of the amplifier. I told you about the concept of sensitivity, which we derived as 1 over 1 plus A beta. It was del AVF by AVF by del AV by AV. Now this fractional change in closed loop gain is 0.1% or 0.1 by 100. Okay. If you want to come into fraction from percentage, you have to divide by 100. But what is the fractional change in open loop gain? Fractional change in open loop gain is 10% or 10 by 100. That means 0.01 is 1 over 1 plus A beta, or 1 plus A beta is 100. Okay. Or you can say A beta is 99. So how you will find beta? 99. What is the open loop gain? 1000. So 0.099. That is your first part, beta for the feedback network. So whenever you see it is talking about change in the value of gain or percentage change, variation, all these kind of things, you always have to talk in terms of sensitivity. Now it is asking next the gain with the feedback network. We know that gain with the feedback network is AV over 1 plus AV beta. We have seen 1 plus AV beta is 100. AV is 1000. 1 plus AV beta is 100. So gain with feedback is equal to 10. Okay. So it is based on what we learnt in the first lecture of feedback amplifier. Next problem. An amplifier without feedback. Without feedback means open loop. An amplifier without feedback gives a fundamental output of 36 volt with 7% second harmonic distortion. That means now it is talking about distortion in the output when input is 0.028. Okay. Now we are feeding 1.2% of output into input in a negative voltage series feedback circuit. We need to find the output voltage. If you are feeding the output back to the input, that means we are making it a feedback amplifier. Earlier it was open loop, but now we are making it a feedback amplifier. But first what I need is the open loop gain. So the fundamental output is 36 volt, but the input is 0.028 volt. So if you divide both the things, what you will get is the open loop gain, which will come out to be 1286. Okay, that is the open loop gain of this amplifier. Now it is feeding 1.2% of the output back to the input. So what is beta? Beta is always a fraction, so convert percentage to fraction. It is 0.012. So beta is 0.012. Now I will try and find the closed loop gain. Closed loop gain is open loop gain by 1 plus open loop gain into beta. 1286 by 1 plus 1286 into 0.012. If you substitute this value into the calculator, you will get the value of gain. But it is not asking the gain. What it is asking? Output voltage. So gain is nothing but output upon input. So if you want to find output voltage, you will multiply the gain, this gain, by input. Input is 0.028. Okay. So it will come out to be how much? 2.19 volt. Okay. Directly substitute this value into this AVF. Let us see the next part. It is saying fundamental output is fixed at 36 volt, but second harmonic distortion is reduced to 1%. What is the input voltage? One thing that I told you, while using negative feedback, the distortion is reduced, the gain is reduced, and the bandwidth is increased. So it is saying the distortion with feedback is 1%, but earlier the distortion was 7%. So how distortion is reduced? It is reduced by a factor of 1 plus AV beta. So this was 7% over 1 plus AV beta, means AV into beta is 6. Now what it is saying is we need to find the input voltage for output voltage equal to 36 volt. Now what is the gain of the amplifier? The closed loop gain is always open loop gain over 1 plus AV beta. 1 plus AV beta is 7. So what is this gain of the amplifier? This gain of the amplifier will become how much? Or let me write it like this only, 1286 by 7. This is also equal to V0 by Vs, or you can say 36 by Vs, because it is saying output is 36 volt. Now Vs is equal to basically 36 into 7 by 1286. So it will come out to be how much? It will come out to be 0.196. Okay, that will be the value of supply voltage to obtain fundamental output at 36 volt. Okay, so by the use of change in distortion, I have found out the 1 plus A beta factor, and then I have found the new closed loop gain. Moving to the next problem. An amplifier with open loop voltage gain of 1000 delivers 10 watt of output power at 10% second harmonic distortion when input is 10 millivolt. If 40 dB negative voltage series feedback is applied and output power should remain at 10 watt, determine required input signal and percentage harmonic distortion. Okay, so it has given us that the open loop gain is 1000, but feedback in dB is actually 40. This I told you is 20 log, take magnitude because it is positive, 20 log magnitude of closed loop gain by open loop gain. So it will come out to be 20 log 1 plus A beta. Okay, Actually it will be 1 upon 1 plus a beta, but to make it positive I am taking 1 plus a beta. So 2 equal to log 1 plus a beta, or you can say it is log on the base of 10. 1 plus a beta is 10 to the power 2, or you can say 100. Now open loop gain I know 1000. From here I can tell about beta. 99 by 1000 0.099. That is your beta. Now it is saying output power should remain 10 watt. If output power is constant, the output voltage will also be constant. Okay. So how much output voltage we need? Earlier output voltage was gain multiplied by input. Gain multiplied by input. So it is 10 volt. We need it to be constant because output power must be constant. But the new gain is how much? A upon 1 plus a beta, that is 10. 1 plus a beta is 100. That means V0 by Vs is 10, or you can say Vs is V0 by 10, 1 volt. So what is the required input signal? 1 volt. But due to negative feedback, the distortion will also be reduced. Earlier the distortion is 10%, but now it will be 10 by 1 plus a beta. 1 plus a beta is 100. 0.1%. Okay. So by the use of negative feedback, we have reduced the distortion, but the gain has also reduced. So if the gain reduces, for same output voltage, we need more amount of input voltage. Next problem. The following circuit is an example of. We need to judge the nature of feedback. What did I tell you? Replace op amp by its internal circuit. This is the internal circuit of op amp. What is this Vi? Vi is the voltage across Ri. Now see this connection. R2 is connected between negative terminal and V0. This is R2. And R1 is connected between negative terminal and ground. This is R1. This voltage is your Vs, this current is Is, and the current in Ri is Ii. Now see the input side. You can directly say that input current is same as source current. So no feedback in terms of current. If there is no feedback in terms of current, what it will be? It will be voltage mixing, or you can say series mixing. That way I can directly judge the nature of mixing. Now what I need to find is the nature of sampling. If it is voltage mixing, what I will say? Make input current equal to 0. For voltage mixing, make current 0. For current mixing, make voltage 0. If this input current is 0, then the current from here will be the same current going here. They will be in series. If they are in series, what is the voltage here? V. This V can be written as V0 into R1 by R1 plus R2. And what about Vi? How you will write Vi? Vi is Vs minus V. So this V is the feedback voltage which is being subtracted from source, and this feedback voltage is proportional to V0. So what you can say? Voltage sampling or shunt sampling. So what kind of feedback it is? Series mixing, shunt sampling. So series shunt feedback. Okay. And you also know the value of beta. This is your feedback factor beta. I told you if you derive the feedback quantity, the proportionality constant will directly give you the value of beta. Okay. So that is how you judge the nature of feedback. Next, what is the effect of series feedback in input and output impedance? Directly, both connection are series. In series, the resistance increases. So we will say input resistance with feedback is greater than open loop input resistance. Output resistance with feedback is greater than open loop output resistance. So in one line you can say both input and output resistances increase. Okay. So that is the effect of series feedback. Next, the following circuit is an example of. Again, how you will start? We will draw the internal circuit of op-amp. This is Vs R1. In internal circuit, we will have a resistance Ri. But remember, the voltage across Ri should be from positive to negative. So, like this. So it will be Vi. Then this positive terminal is grounded. Okay. Then this voltage is AV Vi in series with the output resistance R0. We get V0. Now V0 is connected to negative terminal like this. Okay. Now see, this current is Is, this is II. Now see one thing, can you say Is is equal to II? No, because there is one more branch connected here. Okay, there is one more branch connected here. Is is not equal to II. So directly I can say it is talking about current mixing, because if it was not current mixing, the source and the input current would be equal, but both are not equal. Otherwise you can do one more thing. This voltage is Vs. If you apply KVL, what you can tell about Vi? Vs minus Is R1 plus Vi equal to 0. So Vi is minus Vs plus Is R1. Now in this term there is no feedback, so it cannot be voltage mixing, it is actually current mixing. Is it fine? Or you can say shunt mixing. Now if it is current mixing, what you have to do? Make voltage equal to 0. If it is mixing the current, make voltage equal to 0. If you make Vi equal to 0, this terminal will be grounded. So how you will write this I? I can be written as 0 minus V0 by R2. That is minus V0 by R2. So I is proportional to V0. So you can say voltage sampling or shunt sampling. So what kind of feedback it is? It is shunt feedback. Okay. So what I have done? Based on the input loop, I have decided whether it is applying KCL or KVL to determine the nature of mixing, and then I have figured out which quantity is to be made 0 and found out the feedback factor. So what is beta here? Beta is actually 1 by R2. Next problem. An amplifier has an open loop gain of 10 to the power 4, input resistance 50 kilo ohm. Find the input resistance of series shunt feedback with a feedback factor of 0.1. The input side we have series connection. Due to series, input resistance will increase. If input resistance increases, you will write RIF is RI 1 plus A beta. 50 kilo ohm 1 plus 10 to the power 4 into 0.1, that is 1000. So it is approximately 50 mega ohm. Okay, as simple as that. For series the resistance will increase, for shunt the resistance will decrease. Next problem. A low pass filter with cutoff frequency 30 Hz is cascaded with high pass filter having a cutoff frequency 20 Hz. Find the resulting filter. We are cascading it. If we are cascading it, it means first the response will be like this. We are cascading low pass filter with a high pass filter. Now it will be passed through the high pass filter. What high pass filter is saying? It will pass the frequencies above 20 Hz. But what frequencies do we have? We only have frequencies below 30. It is saying it will pass above 20. It is saying below 30. So the intersection will be from 20 to 30. So what kind of filter it is? Band pass. Simply just think that high pass filter is passing above 20, low pass filter is passing below 30. So their intersection will be from 20 to 30. So that way it will be a band pass filter. Next question. An amplifier has open loop gain 100. Lower and upper cutoff frequency are 100 Hz and 100 kilohertz. A feedback network with a feedback factor of 0.99 is connected to amplifier. Find lower and upper cutoff frequency. Okay. See, due to negative feedback, what do we know? Due to negative feedback, gain reduces, distortion reduces, and bandwidth increases. If bandwidth increases, the lower cutoff frequency should reduce. What I mean to say, I showed you in frequency response as well that earlier the gain or frequency response is like this, but now it is like this. The gain is less, but lower cutoff frequency is lesser than before, and upper cutoff frequency is more than before. So that is what I am saying, lower cutoff frequency should reduce. So how much will it be? 100 by 1 plus 100 into 0.99. So it will be 1 Hertz. But upper cutoff frequency must increase to increase the bandwidth. So it is 100 kilohertz. 1 plus 100 into 0.99. That is 100 into 100, or you can say 10 megahertz. So remember, the lower cutoff frequency will reduce and the upper cutoff frequency will increase, due to which overall bandwidth of the amplifier will increase. Next problem. Again we have to find the nature of feedback. Okay. So if you observe this circuit carefully, it is an example of collector to base bias in BJT. Now in BJT, the input voltage is the base to ammeter voltage and the input current is base current. See, This is the source current. Can you say, can I say IS is equal to II? See this? No. Because this resistance RB is also carrying a current I. So we can't say like this. So what I'll say? It is an example of current mixing or shunt mixing. So as simple as that, if the source current is equal to input current of the amplifier, then it is voltage mixing. If both are not equal, then it is current mixing. Just observe this small thing. Okay. Now, if it is current mixing, what I have to do? What I have to make 0? Voltage. Make VI 0. If I make VI 0, this terminal will be grounded. Then what will be I? I will be 0 minus V0. The voltage of this terminal is V0. 0 minus V0 by RB, or minus V0 by RB. So this I is proportional to V0. So it is voltage sampling or shunt sampling. So what kind of feedback it is? It is shunt feedback. Okay. So just observe the current coming out of the source. Is it the input current of the amplifier? Next problem. An amplifier having open loop gain of 100, input resistance 1 kilo ohm, output resistance 100 ohm. A feedback network of feedback factor is 0.99 is connected to the amplifier in voltage series. Find input and output impedance. So first let us observe this voltage series. In this naming, the first term represents sampling and this one is mixing. If you are sampling the voltage or if you are observing the voltage, you have to observe in shunt. So that means at the output side we have the shunt and at the input side we have series. Due to series, the input resistance must increase. Okay. That means 1 kilo ohm 1 plus 100 into 0.99. It will become 100 kilo ohm. But due to shunt output, the output resistance will reduce. R0 over 1 plus A beta. So 100 over 1 plus 100 into 0.99, that is 1 ohm. So just judging the nature of the feedback, you can tell which resistance will increase and which resistance will decrease. Next, the feedback topology in the amplifier circuit shown. Okay. Again, the input voltage is nothing but the base emitter voltage and the input current is the base current. Now this is IS. Now I will ask you the same question. Can I say IS equal to II? Is IS equal to II? You will say yes. IS is equal to II. That I can see directly. That means no current mixing. If there is no current mixing, what mixing will be there? Voltage mixing or series mixing. Now once I know voltage mixing is there, what I'll say? Which quantity will I make 0? Make input current equal to 0. Now see, this input current is actually the base current. If base current is 0, IC is actually equal to IE. But when we talk about amplifier, what we do actually? We remove the DC supply. So in this amplifier, let me remove the DC supply. Even if you want, you can make the model also. So I am making RPi model. These models we have seen multiple times. Okay. This terminal will be grounded, so RC will be connected between collector and ground. Now this is V0. So if I ask you, what if you make IB equal to 0, then this current will be beta IB. What is the current in the output resistance RC? The current in the output resistance RC is actually beta IB. So you can say I0 is minus beta IB, and it is same as, because I0 should be like this, it is same as minus IE. Now if I ask you this VI, so you will apply KVL. What you will say? VS minus IBRS minus VI minus VE equal to 0. VE is this voltage. Okay, but IB has been made 0. So what is VI? VS minus VE. How you will write VE? VS minus IE into RE. But this IE is proportional to I0. That means the feedback voltage is proportional to I0. See, IE and I0 both are equal. So that means in voltage mixing, this feedback voltage is directly proportional to I0. If it is directly proportional to I0, it is current sampling or series sampling. So series mixing and series sampling, it is an example of series feedback. Is this point clear to you? First of all, I have identified what kind of mixing is there, and due to voltage mixing I have derived the feedback voltage, and it is directly dependent upon I0. That is why it is current sampling or series sampling. Next question. A cascade connection of two voltage amplifier is shown in the figure. Actually figure is mixing. So let me draw the figure. This is A1. This is A2. The input and the output resistances are also given. We have to find the overall voltage gain. Now whenever input and output resistances are given, this is an example of multi-stage amplifier. Whenever input and output resistances are given, in that case there is loading effect. Due to loading effect, we cannot directly multiply the gain of the amplifiers. I will write A1 is AV1 into voltage division. What voltage division? Ri2 by Ri2 plus R0 1. That is 10 into 5 by 5 plus 1. That is 50 by 6. What about A2? For A2 you need to know the load resistance. Okay, the load resistance is not given here, but that should have been given. It is 1 kilo ohm. Okay, it is 1 kilo ohm and it is 200 ohm actually. 200 ohm. Okay. So A2 is again by voltage division, AV2 RL by RL plus R02. This concept I have already taught you in multi-stage amplifiers. In multi-stage amplifier, whenever input and output resistances are non-zero, then you have to use the voltage division. 1 by 1 plus 200 ohm is 0.2 kilo ohm. So 5 by 1.2. Now you can multiply the gain after considering the loading effect. 50 by 6 into 5 by 1.2. So it will come out to be 34.7. So those who haven't studied multi-stage amplifier, in that case this question is out of course. But if you have studied multi-stage amplifier for ESE or GATE ECE, then you know what formula I am using. This I taught in the multi-stage amplifier in BJT. Moving to the last question. In the AC equivalent circuit shown in the figure, IN is the input current and RF is very large. Find the nature of the feedback. Okay. Now see. In MOSFET, gate current is 0. So the input current is the source current. Now can you say that IN is equal to II? No. That means there is current mixing. Okay. So there is current mixing, there is current I going in RF. Now you can say II is IN minus IF. If it is current mixing, what I will make 0? Make input voltage as 0. Making input voltage 0 means grounding this terminal. This is the input voltage, I am making it as 0. So I am grounding the terminal. Then what is this current I? This is not IF, simply I is 0 minus V out by RF. That is minus V out by RF. So I is proportional to V out. You can say it is voltage sampling, or you can say shunt sampling, and due to current mixing it is shunt mixing. So what feedback? It is shunt feedback. Okay. So that is how you determine the nature of the feedback. If you remember the steps that I have applied, it is very simple to judge the nature of feedback. I hope now you know there can be two type of problem. One based on the first lecture that we studied about feedback amplifier, and second about judging the nature of feedback. This is all from this video. From the next one we will start the oscillators.
I hope all of you have enjoyed the lecture that we were providing, and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series, and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil, and Telugu, JEE channel, Computer Science, Gate Question, and Electrical Junction, Pathshala, and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these two channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like, and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.